Hey guys, this is gonna be a video covering the 2.4C homework. Starting off here, you are living in Phoenix with and a taxi company charges a flat fee of $3 for using the taxi and 75 cents per mile. Write an equation that you could use to find the cost of the taxi ride in Phoenix. So starting with A. Now the given information here, the flat fee, if I'm going to apply this to a linear model, this would be my y-intercept. And then the 75 cents per mile, that would be the slope. And so creating a linear model, y equals 0.75x plus 3. So that would be a linear model, an equation that we could use to find the cost of the taxi ride in Phoenix. How much would a taxi ride for 8 miles cost? So using this model, I'm going to plug in 8 for, I'm also going to write 0.75, that's the same thing as 3/4. So I'm going to plug in 8 for x, because that represents miles, plus 3, and then just do some math here. Well, so let's see, that's going to be the same thing as 24 over 4 plus 3. 8 times 3 is 24, and then 24 divided by 4 is 6, so 6 plus 3, and that's going to be 9, and that's 9 miles. How much would it cost? No, not miles. No, it's going to cost $9. There you go. $9. Okay, and for part C, if a taxi ride costs $15, how many miles did the taxi travel? So in this case, I'm going to use 15 in place of y. And then, oh, I don't need to put an 8 for x. This is just going to be x, because x is what I'm solving for. X is the amount of miles. So I'm going to subtract 3 from both sides right here. So subtract 3, and I'm going to get 12 is equal to 3 over 4x. And in order to get rid of the coefficient here, I'm going to multiply by its reciprocal. So I'm going to multiply this expression by 4/3, because what that will do is cancel the 4's and the 3's, but I also need to multiply the other side by 4/3 as well. And so in this case, 4 times by 12 is 48. So 48 over 3 is going to be equal to x, and 48 divided by 3 is equal to 16. So x will be equal to 16 miles. So that's how far you could go with $15. Next question. Afton is tracking the progress of her plant's growth. Today the plant is 5 centimeters high. The plant grows 1.5 centimeters per day. So again, the plant is 5 centimeters high, and this is when she's tracking her progress. So we'll count this right here as the y-intercept. So we'll say b is equal to 5, and the plant grows at 1.5 centimeters per day. So we'll say m is equal to 1.5. Okay. Find an equation that represents the plant's height after any given number of days. So creating an equation, we'll just say y is equal to 1.5x plus 5, like that. And then b, how tall is the plant after 9 days? So I'm going to use this equation, and I'm going to substitute 9 in for x. I'm also going to write 1.5 as 3 halves, because I like working with fractions rather than decimals. But so we got 3 halves times by 9 plus 5. Do some math right here. So 3 times by 9, that's going to be 27. Right, so 27 halves plus 5. And oh man, that's too bad. 27 does not go into 2. But I guess we can go back to using decimals then. 27 halves is 13.5. So 13.5 plus 5, that's going to be equal to 18.5 centimeters. So that's how tall the plant is expected to grow after 9 days. While on vacation in New York, the cab ride from the airport to the hotel is 15 miles. The total cost of the cab ride was $25.50. The cabbie charges $1.50 per mile for the entire trip. Write an equation that can be used to determine how much a cab ride would cost anywhere in New York. So writing an equation, let's see. The cab ride from the airport to the hotel is 15 miles. The total cost of the cab ride is $25K. And the cabbie charges, so this right here is going to be our slope. M is going to be equal to 1.50 or just 1.5. Now, the thing is, we're not really given an initial value, right? So the cab ride from the airport to the hotel is 15 miles. The total cost is the cab ride is $25.50. Okay, so in this case right here, the total cost, so say that we had the equation y is equal to mx plus b. So the total cost was $25.50. So we can go ahead and substitute that in there. You don't really need an equation for this either. I mean, you can figure this out just by doing some scratch work on a piece of paper. But sometimes the equation kind of helps you organize everything. But the total cost is going to be $25.50, and that's after 15 miles, right? And so it's $1.5 for every mile, and we're going 15 miles, right? And then we'll say plus b. This right here will indicate the initial cost, if there is any, right? And so if you go 15 miles for $1.5 per mile, that's going to be, this is why I like fractions more, 3 halves times by 15, 15 times by 3 is going to be 45 over 2, okay. So we get 25.5 equal to 45 over 2 plus b. So is that 22.5? So 25.5 is equal to 22.5 plus b. And then I'm going to subtract that from this amount right here, and then that will give me my initial value. So b would be equal to 3. So the initial cost of the cab ride was $3. So to kind of write just the general formula, we'll say y is equal to 1.5x plus 3. That should fit our formula if I did my mental math okay. And that should check out. So again, if I did 1.5 and I plugged in 15 right here, I already did the math backwards. This will come out to be 25.5, so it should fit our situation. For B, what is the flat rate of the cab ride? Well, we found that before. It's $3. C, how much does it cost to travel 7 miles in the cab? So just using the same formula, y equals 3 halves times by 7, so for 7 miles plus 3, and that's going to be equal to 21 halves plus 3. 21 halves is at 10.5. 10.5 plus 3, and then that's $13.5 dollars. Okay. An internet service provider charges $18 per month. All right, remember, if it's at a rate, that's going to be slope, so M is going to be equal to 18. Plus the initial setup fee. Doesn't look like that's given to us. One customer paid $81 after 2 months of service. Okay, now in this case right here, I'm going to opt out to use the point slope form. So y minus y1 is equal to m times by x minus x1. Maybe it would have just been easier to write that up here. 15 miles, yeah. We definitely could have just used this point slope form in the previous example above, but I guess it was good just to do some math. But I'm going to use this right here. And remember, point slope form just involves using a point, so a given x and y value, and the slope. So we know that the slope is 18. And then we do know a data value from the information given to us. It was $81 after 2 months, so x1 would be 2 and y1 would be 81. And so for A, I'm just going to write y minus 81 equal to 18 times by x minus 2. And if you want to format this into the given equation above, you can add 81, distribute, and then combine like terms. So y will be equal to 18x minus 36, right? Plus 81. Okay. And then 81 and minus 36. Let me get that right here. It's 45. So we can say y is equal to 18x plus 45. So the reason why I did all this right here is because B is asking for the initial setup fee, so we found that to be equal to $45. Man, I wish things were this cheap. Let's see, how much does it cost after 5 months of service? So for C, we'll say y is equal to, so it's $18 per month, and we want it for 5 months, plus the initial setup fee, which was 45. Okay, so 18 times by 5, let me get that. That's going to be equal to $90, plus the initial setup, so plus 45, and that's equal to $135. There you go. Okay, on to piecewise functions. Write a piecewise function for the graph. So in this case right here, we'll do y equals. We're going to have 2 different parts of this graph right here because we have 2 equations. So starting with the furthest most left, let's get an equation for this piece right here. I can see that we have a slope of 1, okay, and a y-intercept at 2. So that part of the equation is going to be x plus 2. And for values x is less than, I'm going to say equal to 0. So this right here describes this part of my graph, this piece, and for the next piece, it's a constant function at y equals 2, and so it's simply just going to be 2, and this is going to be for, I'll say x is greater than 0. Because they're intersecting at the same point where you put them together, it doesn't matter where you assign that equal to. I don't mind in any case, so. But not on both. Okay, example 2. so we have two pieces yet again, so y is equal to the first piece, the furthest most left piece, is a constant function. This is happening at -3, so we'll say -3, and that's when x is less than or equal to 0. And then the other function, which is going to be linear, it has a slope over 1 and down 3. Now, reading it left to right, it is decreasing, and so that has a negative slope, so -3x, and its y-intercept would have been 3 if it touched the y-intercept, or the y-axis, and this is where x is greater than 0. Okay, let me erase that right there, because I did that with my other class. And we'll get to it too. So question 3, we have these two pieces right here. So y is equal to this graph right here, the furthest most left, has a slope of -1 and a y-intercept at 0. So that's simply going to be -x. Now this right here, you can see that the pieces are being broken up at x equals 4, and so this will be for x is less than 4 but not including 4. And the other piece, that's where it's going to start. Now again, the slope here is -1, so it is going to be -x, and if this did intercept the y-axis, you have to consider that. So if this continued its path up here, it would have a y-intercept of 1. So +1, and this is for x is greater than 4. Alright, question 4, we have two pieces. The first piece has a slope of, looks like it's going to be 2, and it is positive, so we're going to say 2x. Now we have to consider where it's going to cross the y-axis, so up 2 over 1, and then up 2 and over 1, so that would be at +2 on the y-axis. So +2, and this is when x, now these pieces are being joined together at x equals -2. So that's for x is less than, I'll say, or equal to -2. And the other function has a slope of up 1 over 2, so that has 1 over 2x, and then we'll say -1 for its y-intercept, and so that's going to be for x is greater than -2. Okay. For 5, we got 3 pieces. The first piece is constant at +1, so we'll just say 1, and this is when x is going to be less than or equal to -2. That's where this one ends, and this other one's going to begin. So this other one right here, this one has a slope of 2, so 2x, and its y-intercept is at 0. And this right here is going to be between, so this is going to require our compound inequality. Less than x is less than or equal to. On the left side, you're going to put the lowest y value of this interval, so that's going to be -2. And then on the right of this right here, we're going to put 0. So this is ranging from -2 to 0, -2 to 0. And then our last piece right here, let's see, the slope in this case right here, looks like we go 1, 2, 3, 4, or yeah, just over 2 and down 1. So, and it's negative, so it's going to be -1/2 x plus 2. And this is going to be when x is greater than 0. Alright, question 6. So y is equal to this first part right here. Looks like we just have a slope of 1. So that's going to be x. but the y-intercept, if I go up 1 and over 1 more, that's going to be at 4. So x plus 4. And this is when x, so this is going to stop at -1 on the x-axis. So x is less than or equal to -1. The next function that we have, over 1, 2, 3, 4, down 1. So this has a slope of -1/4 x. And that means that this y-intercept, so if this is over 1, over 4, and down 1, that means every step I go over is a fourth. So that's a fourth, that's a fourth, that's a fourth, and that's a fourth. And so the y-intercept will be -1/4. And this is going to be a compound inequality. We're going to write this between -1 and 1, 2, 3, and 3. So between -1 and 3. And then our last piece right here is constant at -3. So it's -3, and that's when x is greater than or equal to +3. Okay. Question 7. This is a step function. So y is equal to. Step functions are pretty easy. They're just constants. So this constant right here is -5. So -5. The next step is going to be at -3. The next step is going to be at -1. And now we do need to put in the domain part. And so for -5, this is between -5 on the x and -3 on the x. So we'll say -5 is less than or equal to x is less than -3. And then this piece right here, this is between -3 and -1. So we'll say -3 is less than or equal to x is less than -1. And then the next piece is going to be -1 is less than or equal to x, and that's going to be less than +1. And then finally, for this last one, y is equal to, we have 4 different pieces, still a step function. So this is constant, so it's going to be constant at 4, and then at 3, and then at 2, and then at 1. So it's going to be constant at 4 between 0 and 1. So 0 is less than x is less than or equal to 1. Then for the next one, 1 is less than x is less than or equal to 2. And then 2 is less than x is less than or equal to 3. And then 3 is less than x is less than or equal to 4. So again, that's happening. This is between 0 and 1. This right here is between 1 and 2. And then it's going to be 2 between 2 and 3. That's what we have here. And then it's going to be 1 between 3 and 4. There you go. Alright, so now we're going to get into some actual graphing. So graph the step function. This is a step function. So the first step is 3. And this is going to be between 0 and 2. So open circle at 3, and it's going to be 3 until 2. And then the next step is going to be 4. So we're going to be here, but only between 2 and 4. So between here and here. And so closed circle here, open circle here, graph in between. Next is going to be 5. So we're going to be here, but only between 4 and 6. So between here and here. So it's going to be open circle here, open circle there. And then 6 is going to be closed circle here, and then open circle there. There you go. Now for the domain. Domain is what values of x does this function have? Well, the good thing is that it's all described pretty much here. We go from x equals 0 all the way until x equals 8, but not including 8. So I'm going to say the domain starts at 0, it's less than or equal to x, and that's going to be less than 8. Okay, now the range. So if I look at the range, what y values does this function have? What are the y values? Well, it's the step function, so these values are the y values. It's 3, it's 4, it's 5, and it's 6. So I'll just say that right there. So y is equal to 3, 4, 5, and 6. These are the only y values of our function. Okay, coming on to this one right here. So our constant's going to be -4, and that's going to be from 1 to 2. Open circle right here, and closed circle right here. And then it's going to be -6 with an open circle at 2, and then a closed circle at 3. And then it's going to be -8, but from 3 to 4, so from 3 to 4. Open circle on the left, closed circle on the right. And then it's going to be -10, open circle on the left, closed circle on the right. And there you go. So the domain in this case, the x values start as low as 1 and go as far as 6, right? So you can see we're covering all the x values in between. However, we don't include 1. 1 is not included in the domain. That's going to be less than or equal to 5. So that's our domain. And the range, the y values of our function, well, that's only happening at -4, -6, -8, and -10. So these values right here. So y is equal to -4, -6, -8, and -10. These are the only y values of our function. More step functions. I'll let you guys do these ones right here. Okay, I'll do them really quickly, but I'm probably not going to explain them much, but I'll do them for the sake of you checking your work if you want. So we're going to be at 9 from 1 to 2. From 1 to 2. So it's going to be open and closed circle there. Very small. And then we're going to be at 6. Open circle at 2. Closed circle at 4, like that right there. And then we're going to be at 5 with an open circle at 4. And then to 9, that's going to be a closed circle right there. And then it's going to be 1 from 9 to 12. Okay, the domain is going to range from 1 is less than x is less than or equal to 12. And the range, y is going to be equal to 9, 6, 5, 1. I guess you could write that in the other order, 1, 5, 6, and 9, but I guess it also doesn't matter too much. Okay, here, so we're going to be from -6 to -5. We're going to be at -2. So closed circle here, open circle here. Then we're going to be at -1. That's going to be closed circle here, and that's going to go until -3. And then we're going to be at 0 from -3 to -2. And then we're going to be at 1 from -2 to 0. And then our domain, that's going to be from -6, less than or equal to x, and that's going to be less than 0. And we'll say y is equal to -2, -1, 0, and 1. Okay. Alright, for this last page right here, these are not step functions, they're just piecewise functions. So we're going to have the graph of -x. So -x looks like this right here, by the way. Slope of -1 crosses through the origin. But we want to show this when x is going to be less than 2. So we only want to show this for that part right there. Okay? So we're going to open circle. I'll put open circle right there. Then just draw my graph like that. And the next graph is going to be x minus 6. So that's positive slope. But it's going to look like this right here. But I only want to draw it from this point right here onward. So like that. And so, yeah. So in this case right here, I would have intercepted right here. but I'm not going to draw the graph right here because I'm going to start drawing it at 2. And so here, if it has a slope of 1, it's going to go up 1 over 1, up 1 over 1. This is where I'm going to start drawing that graph right there. So right here. And then draw my line with the slope of 1 right there. Domain is still all real numbers in this case right here. This is going to be all real numbers because we're covering all the x values over here. We're covering all the x values over here and everywhere in between. So every x value is covered. X equals 2, we do have a little bit of a switch where we're going to this function right here, but we're still covering all the x values. So domain is all real numbers. In the range, we're going to cover all y values as low as -4. So all y values as low as -4 are going to be covered in the piecewise function. So we'll just say y is greater than or equal to -4. Alright, in this case right here, we have a parabola. So, yeah, let's graph this one first. This is the linear function. We're only drawing it on the left side of the y-axis because that's when x is less than 0. So this one has a y-intercept at -1. That's going to be open circle right there. And then it has a slope of -2. So make sure you draw this going down into the left. So again, this has negative slope, so it should be angled this way. So reading left to right, I should be decreasing. Okay? Then we have x squared plus 1. So this is a quadratic shifted down 1. So that's going to put the point right here, and then I'll just use the 1, 3, 5 rule. So 1, 3, and 5. So I have my quadratic function like that right there, but I'm only drawing it for x is greater than 0. And there's our piecewise function. So the domain of this piecewise function is still all real numbers. We're covering all x values, and the range is as low as -1. So we'll say y is greater than or equal to -1. Okay, for 15, we have 2x, x squared, and -2x. So 2x is going to look, well, also pay attention to the spacing here. So each of these is worth 2, each of these is worth 1. So 2x has a y-intercept of 0 and goes up 2 and over 1, up 2 and over 1. So it's going to look something like this right here. But we only want to draw it for values that are less than -2, so values that are left of here. Okay? So it would have intercepted here, but I'm going to work backwards. It would have had a point here, and then this is where I'm going to start drawing my graph. Right there. Has a slope of -2. So over 1 and down 2, over 1 and down 2, over 1 and down 2. And I don't need those right there. For the next piece in between, that's x squared. And so I'm only going to draw this from -2 to 4. So x squared has the vertex here. And then you'd go up 1 and over 1, just using the 1, 3, 5 rule. And we're going to go over 1 and up 3, so that would put me at 4. So right there, those would be my points. Now notice here that there's supposed to be open circles on the end. So instead of drawing these as circles filled in, I'll do an open circle and an open circle like that. Okay? And then for our last piece, we have -2x. Now -2x, it's just going to be the same as this graph, but going down this way. And so, just really quickly, I'm going to draw that. That's going to be closed circle here. And then going down like that. So that's what this function is going to look like. Its domain is still going to be all real numbers. We're covered for all x values. Okay, definitely jumping around, but we're still going to have every x value. The range is going to be weird. So the range, I'm going to do in 2 different pieces. So I'm going to say when x is less than -4 because of these two pieces right here. Sorry, y is less than or equal to -4. So y is less than or equal to -4. And then for the next part of our range, we're going to be between 0 and 4. So that's going to be a compound inequality. So I'll say y is less than, or equal to. So the lowest y value is 0. So that's going to go on the left side of this compound inequality. And the highest y value is going to be 4, but not including 4. So very, very weird range, but those are all the y values of our function. Okay, and then for this next part right here, we have 2x plus 1, and then we have x is less than or equal to -1. So 2x plus 1, so that's going to be if we had a point right here, but we only want to draw this to the left of -1, so just to the left of that. It has a slope of 2, so the next part would be right there. So right here is where I'm going to start drawing it, but I'm going to draw it going to the left. So we'll have a point right there. So over 1, down 2, over 1 and down 2. Like that. So that's 2x plus 1, but only for values less than -1. Our next piece is going to be -x plus 2. So that's going to have a y-intercept at 2, but it's going to have negative slope. So we'll have an open circle right here, then a dot right here, then a closed circle right here. So that's what this graph is going to be right there. And then we're going to have a constant function for the rest. So that's going to be down at -3. That's going to be a closed circle. Oh, whoops. Sorry, this right here is an open circle, not a closed circle. And then this is going to be closed, but it's just going to be constant at -3. And there you go. Domain is all real numbers. The range, so we're going to cover all y values. Looks like we do have a little a gap right here, so we're not including y values in between -1 and 0. And then we're going to include values between 0 and 3. So again, this one's going to be kind of weird. I'll say this right here, y is less than or equal to -1. So that's for all the y values up to this point. We're going to skip these values right here and go to 1, go to 0, but not including 0. So we'll say 0 is less than y, and that's got to be less than 3. That's for this part right here. So the y values of this part are from 0 to 3. Okay. And that's everything for this homework assignment.